Hi everyone, we're just going to go over the questions that you have assigned for notes today. They are going to be the sheet titled Solving with Completing the Square dash Irrational, because when we complete the square for these, we are going to get irrational answers only. So the directions for this first part are showing you some quadratics, and it says find the zeros of that quadratic function. So in order to find the zeros, what we would be able to do is replace the f of x with 0. So when we go ahead and do that, we would then follow our first steps for completing the square, which is to get the constant value over on the side other than the variables are currently on. So for this, we'll get negative 2 equals x squared plus 6x. We will then take half of our b value and we will square that. So in this case, our b value ends up being 6. So we are going to add 3 squared to both sides. So we will add 9. That's going to enable us to have 7 equals, parentheses, x plus 3 all squared, since x squared plus 6x plus 9 ends up being a perfect square trinomial. So when I take the square root of both sides, I end up with positive and negative square root of 7. A lot of the other times when we've been dealing with this so far, we've been getting perfect squares on the other side, so that when we take the square root, it hasn't been an issue. But here, we cannot take the square root of 7. If it could be simplified, we would have. This one in particular can't be. When I subtract 3 from both sides, because that does not have a radical, it is not going to be a like term. And so what we're going to have as our final answer is negative 3 plus or minus the square root of 7 as the values for x that would be considered the zeros of this function. In the event that you were asked to round these answers, the two answers, because of the plus minus sign, we would end up taking negative 3 and first maybe subtract the square root of 7 from that if I wanted to do the lower value first. And it's about negative 5.6. If I did the same thing but I hit the plus instead on the calculator, we would get negative 0.4 approximately. But this one doesn't provide rounding instructions. It just says find the zeros, and that's as complete as we can be. If we look at question 2, which is down below, we'll be able to do the same thing again. Set 0 as what my output is, and then I'll go ahead and copy the rest of the problem. In this instance, because the leading term is not a 3, I'd have to divide both sides by 3. Conveniently, everything was a multiple of 3. With n squared minus 6n plus 11. So I'm going to subtract the 11 from both sides. And that's going to give me negative 11 equals n squared minus 6n. Now that b value is 6, just like the last problem's b value that we did was. So that means we're adding 3 squared to both sides again. So when I go ahead and I do that, I'm going to end up adding 9. And what you'll notice is this time, when I add the 9 to both sides, I end up with negative 2 equals x minus 3 all squared. When I tried to take the square root of both sides, we actually revealed that my heading for today's lesson is actually a little bit misleading, because not every answer is going to be irrational in these instances. In fact, we cannot take the square root of a negative number. This actually reveals that this has no answer or no zeros. If you wanted to see why that's the case, you could go ahead and graph this on your calculator. You would see it doesn't hit the x-axis. That's why there's no zeros. So because we ended up having a situation where we tried to take the square root of a negative, this was an impossible problem. All right, question number 3. We'll see which of the two situations it is. When I set this equal to 0 to find the zeros of the function, is this going to give me an irrational answer like question 1 did, or is this going to give me a situation where I have no answer because we can't take the square root of a side? Well, already we can see I have a 2 equals x squared plus 8x, so I'm not going to have the negative issue this time around. I'll go ahead and cut the b value in half and square it, showing I would add 16 to both sides. And so I get 18 is equal to x plus 4 all squared. I'm going to take the square root of both sides. So I have the positive and negative square root of 18 equaling x plus 4. I'm going to go ahead and subtract 4 from both sides. Once again, they're not like terms, so it's going to be negative 4 plus or minus a radical. But this time around, this radical can be simplified. So if I went to simplify that, what I would end up getting is 9 times 2 inside the square root, or 3 radical 2. And we would consider that our final answer to this question. Those would be the zeros of this function. You could check this on the calculator just like I suggested you check number 2. You would go to your y equals menu, and you would type in this equation. Y equals x squared plus 8x minus 2. If you go ahead and type that in, you will see it does hit the x-axis this time. It's just it's hitting it at irrational values. So if you hit the trace button, and then you typed in negative 4 minus 3 radical 2, you'd see that's where it hits the x-axis. If you did negative 4 plus 3 radical 2, you'll see that's the other spot it turns around and hits the x-axis at as well. At this point, if I went a little fast through these, you might want to scrub back and redo question 1, 2, or 3. Okay, pause the video if you need to, catch up. All right, but once you're ready, unpause it and go to question 4. All right, so for this one, once again, it's continuing the instructions of find the zeros of this quadratic function. So I will go ahead and set the output to 0. I'll have to divide everything by 2. So 0 would equal a squared plus 6a plus 5 halves, or 2.5, which I will now move to the other side. So that's going to give me negative 5 halves equals a squared plus 6a, and I will have to add 9 to both sides. So since 9, when it's written in halves, is 18, that's going to be 18 over 2 minus 5 over 2, leaving me with 13 over 2 on that side, and that's going to equal a plus 3 all squared. So I'm going to get plus or minus the square root of 13 over 2 equals a plus 3. And so when I subtract 3 from both sides, my final answer is negative 3 plus or minus the square root of 13 over 2 as the zeros of that function. If you wanted to, you could say negative 3 plus or minus the square root of 6.5. That would be fine. Okay, now the directions change for 5 and 6. Okay, for number 5, it just says solve for the missing variable. That actually doesn't change what we do. We have to exchange what's on each side, so I have the variables together. So I'll subtract 4x from both sides, giving me x squared minus 4x. On the other side, I'll have a 2, and I can keep completing the square now. So half of my b value squared is 4, because that's negative 2 all squared. And so I'm left with x minus 2 squared as my factored part, and 6 on the other side. So when I take the square root of both sides, I get x minus 2 is positive and negative square root of 6. And when I add 2 to both sides, x will equal 2 plus or minus the square root of 6. Again, pause if you need to. Go back and relook at all of that. But otherwise, we'll look at the 6th and final problem. So this one, we would subtract 7 from both sides, so that we can do d squared minus 2d is equal to negative 7. Half of negative 2 is negative 1, and when I square that, I get positive 1. And so we have d minus 1 all squared equaling negative 6. So here's that thing that causes an issue. When we do this, we just tried to take the square root of a negative number. This one would have no answer. And you could check this, even though it's not in the terms of a function, you could check this the same way we checked before. You could type this d squared minus 2d plus 7 into your y equals menu of your calculator, and you would see that this does not hit the x-axis. All right, so we're going to talk more about this tomorrow, so that if there's any questions or clarifications on any of these problems, you can go ahead and ask me. But we had 1 through 3 on the front. We have, oops, that's the homework, sorry, 4 through 6 on the back. All right, and if you need to, go back at any of the points where I did one of the problems and relook at it, pause it, take the notes down, absorb it. Try to think about how the properties of equality are being used, as well as the process of completing the square. If you are done, there is a homework sheet that you can pick up from the front of the room. Okay, but you just have to show that you've done all of these questions. All right, thanks so much.